So this is the problem, the first problem you had on that sheet. And so what were some of the things you thought about or did? How did you decide how to approach this problem?
Wrote the half reaction.
Okay, so what are the half reactions? And in this case, you already have kind of the bromine half reaction, but did you do it a little bit differently, or how did you?
I just pulled the ion plus.
Okay.
The ion plus 2 electrons. Gives you ion 3 plus.
Is it plus 2 electrons?
Yeah, plus 3.
Plus 3 electrons. Sorry,
Is the indium gaining or losing electrons? It's losing electrons.
minus.
So you get indium 3 plus 2 electrons. And so is that going to be an oxidation or a reduction half reaction? That's going to be oxidation. And so is that going to be taking place at the anode or the cathode? That's going to be the anode. Okay? And what's your other reaction that's going on, your other half reaction? It's going to be Br2 liquid gaining 2 electrons to produce 2 Br minus. That's going to be a reduction, and so that's going to be the cathode. Ooh, that was cool. Okay. So now that we know what's the anode and what's the cathode, what's the next thing we're going to do? Well, you're essentially using this Ecell equals E cathode minus E anode. We have the cell potential, I gave that to you. And the bromine in this case is the cathode, so we have that. So we have to rearrange this equation to get E anode equals E cathode minus E cell. So then we plug in the numbers and we get what we're looking for is 1.065 minus 1.46, and with significant figures that's negative 0.40. volts. Okay, so that's an example of how you could use that cell potential reaction to identify the reduction potential of a half reaction that isn't even on that table, 20.1. Because there's going to be a lot of half reactions that, depending on what kind of work you do in your life, there's just a lot of half reactions that are possible. And so this gives you a way to identify what the reduction half reaction would be for a new species. About what we just did, we kind of looked at the half reactions and then we said one's the cathode, one's the anode. How did we decide that one was the cathode and one was the anode?
Which one was oxidation?
Which was oxidized and which reduced. In this next problem, how are you going to decide which is the cathode and which is the anode? In that problem, I want you to calculate the Ecell, and I give you the reaction that we have 2 aluminum and 3 iodine goes to 2 aluminum 3 plus ions and 6 iodide. Is that what I gave you on that second problem? Okay. So in this problem, you have to calculate the cell potential. So go ahead and do that. Okay, so when you're looking at this problem, it works kind of like we did the last one. We have our balanced reaction, and the first thing you want to do is you want to identify what the half reactions are. And so in this situation, we have aluminum metal going to aluminum 3+. So what's going on with the aluminum? It's being oxidized, so the aluminum is acting like the anode. And then the iodine is going to iodide. So how does it do that? It's reduced, and so that means that the iodine must be in the cathode compartment. And so now you know which one is the cathode and which one is the anode. And so now it's simply a matter of Ecell equals E cathode minus E anode. So that's a plus 0.54 for the cathode and a negative 1.66 for the anode, and you should get a positive 2.20. Okay? For the cell potential. Now, if you look at this example, what's the reduction potential for the cathode? It's plus 0.54. And the reduction potential for the anode is negative. So in this case, you recognize that the cathode has a more positive reduction potential. Now go back to the previous problem. What was the reduction potential for the cathode in the previous problem? It was 1.06. Okay. And what was the reduction potential for the anode that we found? It was negative. So one generalization we could make about voltaic cells, for voltaic cells, the more positive reduction potential is going to be the cathode. But that only works if you have indeed a voltaic cell. Because remember, voltaic cells have to have a spontaneous process. And you only get a spontaneous process if the more positive reduction potential is your cathode. So that's a very important piece of information to use later in this chapter.